Welcome all. In this
Welcome
video, we
all.
will learn about
I'm
feedback
Manisha G.
amplifiers.
Krishnan, Assistant Professor, Department of EC, Rohini College of Engineering and Technology, Kanyakumari. We're discussing about electronic devices and circuit. Let's start with
Students will be able to construct an analysis of feedback amplifiers. Feedback amplifier. The amplifier in which a part of output is sampled and fed back to the input of the amplifier is called feedback amplifier. Therefore, at input we have two signals, input signal and part of the output which is fed back to the input. Types. There are two types of feedback amplifier. First one is positive feedback and second one is negative feedback. Feedback network. It may consist of resistors, capacitors and inductor. Most often it is simply a resistive configuration. It provides reduced portion of the output as feedback signal to the input mixer network. It is given as Vf is equal to beta V naught, where beta is a feedback factor or feedback ratio. The symbol beta used in feedback circuit represents feedback factor which always lies between 0 and 1. It is totally different from beta symbol used to represent current gain in common emitter amplifier which is greater than 1. Now feedback amplifier. There are four types of feedback amplifier. First one, voltage series feedback, voltage shunt feedback, current shunt feedback and current series feedback. The voltage series feedback topology with amplifier is replaced by Thevenin's model. Here, AV represents the open circuit voltage gain taking RS into account. Since throughout the discussion of feedback amplifiers, we will consider RS to be part of the amplifier and we will drop the subscript on the transfer gain. Look at the figure and the input resistance with feedback is given as RIF is equal to Vs by II. To obtain expression for Vs, apply KVL to the input side. We get Vs minus IIRI minus Vf is equal to 0. And then obtain expression for V naught in terms of II. To find out the expression for IRIF, substitute the value of V naught in Vs. And then we get the input resistance RIF is equal to RI into 1 plus beta AV. Next, we are going to find out the output resistance. To find out the output resistance, we first draw the equivalent circuit and then obtain expression for I in terms of V, then obtain expression for R naught F. Then we need to find out the R dash naught F, that is R dash naught F is equal to R naught F parallel RL. Then we get the final answer as R dash naught F is equal to R dash naught by 1 plus beta AB. Next, we are going to learn about shunt feedback amplifier, that is voltage shunt feedback amplifier. In this section, we will derive the expression for input resistance and output resistance in voltage shunt feedback amplifier. For that, draw the equivalent circuit of voltage shunt amplifier. Then find out the expression for IS by applying KCL at input node and then obtain expression for V naught in terms of II. Then at last we get the expression for RIF as RI by 1 plus beta RM. For output resistance, we first draw the equivalent circuit, then obtain expression for I in terms of V, then obtain expression for R naught F. And at last, we again find out the expression R dash naught F as R dash naught F is equal to R naught F parallel RL. We get R dash naught F is equal to R dash naught by 1 plus beta RM. Shunt series of current shunt feedback amplifier. To obtain the expression for current shunt and current series feedback amplifier, the same procedure as we already done. That is, the first we need to find out the equivalent circuit, then obtain the expression for IS and then find out RIF, that is input resistance. And after that, for finding the output resistance, first draw the equivalent circuit for the output side and then apply KCL to get the expression for I in terms of V. Then we get the input resistance and output resistance for both current shunt feedback and current series feedback amplifier.